Tired eyes, endless ocean, one mistake, and there's no way home. That's what it felt like inside America's newest bomber in 1944. And here's the twist most people never hear. The B-29 didn't win by being accurate. It won by giving up on accuracy. It was built for high-altitude precision. That was the dream. But over Japan, that dream collapsed fast. Winds, clouds, and reality shredded the plan. In this video, you'll see how the B-29's precision dream collapsed, and why one brutal change in tactics broke Japan's war machine. Because the B-29 did one thing no other bomber could do. It let America hit Japan from far away, over and over. This is where long-range war begins. So here's the question that changes everything. Why did the world's most advanced bomber end up flying like a desperate one? Because the whole story comes down to one thing: distance. Start with one number that changed everything. 1,843 nautical miles. That's how far a B-29 could go and still fight its way home. That meant it could strike mainland Japan again and again from Pacific bases without hopping through extra staging fields. Suddenly, places like Okinawa and the Marianas weren't just dots on a map. They became launch pads for sustained attacks on Japan's industrial centers. That reach changed planning overnight. Instead of needing lots of stepping stone bases, leaders could focus on fewer forward bases that were bigger, stronger, and better protected. But distance created a new problem too: time. Many missions lasted 10 to 18 hours. That forced planners to think about crew fatigue, navigation, and what happens when humans have to stay sharp for half a day in a combat airplane. Those long missions became the benchmark that later shaped Cold War bombers and nuclear delivery planning. But range alone didn't win the war. The B-29 arrived with a huge promise: high-altitude precision bombing. On paper, it sounded perfect. A pressurized cabin so crews could work at extreme altitude, remote-controlled gun turrets for defense, the Norden bomb sight for accuracy, radar like the APQ-7 to help find targets. You'd think that combination would guarantee pinpoint hits. Over Japan, it didn't. Here's the problem nobody could wish away: jet streams. At high altitude, winds over Japan could be brutal. Bombs got shoved off course. Cloud cover often hid targets completely. And the APQ-7 radar couldn't fix everything. After missions, analysis showed these precision strikes caused minimal industrial disruption. Japan's war production also wasn't neatly packed into a few easy targets. Manufacturing was spread out, and a lot of it lived inside big urban areas. High-explosive bombs weren't doing enough damage to sprawling city factories, and high-altitude drops scattered bombs across wide areas. The B-29's high-altitude precision reputation started to look like a myth. That's when America's bomber game plan flipped. Early B-29 raids were getting battered by wind and weather, and results were disappointing. Then, General Curtis LeMay took command in January 1945 and made a decision that shocked people then and still sparks arguments now. He decided the European-style idea of high-altitude, daylight precision wasn't working here. And he went radical. LeMay ordered B-29s stripped of most defensive guns so they could carry much heavier bomb loads. He sent them in at night and much lower, roughly 5,000 to 9,000 feet. He switched from high explosives to incendiaries and used patterns designed to spread fire fast, including X-pattern runs meant to turn neighborhoods into one connected blaze. Tests at WWII Proving Ground had already shown how deadly the M69 incendiary was against Japanese-style construction. LeMay stopped fighting reality and started using it. The results were shocking. Bombing accuracy in this new approach was reported to jump from about 20% to 94% by July 1945. And in a broader sense, some reports describe strike results jumping from single-digit performance into the neighborhood of 80% effectiveness once the new night fire raids became the main method. This was no longer about threading one bomb into one factory. It was about turning entire city industrial zones into ash. The logic was cold and simple. Japan's cities were vulnerable. Many buildings were wooden and tightly packed. Instead of trying to hit one factory through clouds and jet streams, the new plan targeted the war economy inside those cities. This wasn't just bombing cities, it was bombing the places where small workshops, parts makers, and dispersed production actually lived. The destruction was massive. About 175 square miles devastated across 64 urban centers. Area bombing became the main method because, in that environment, it worked better than high-altitude precision attempts. The most famous proof came fast. On March 9th to 10th, the Tokyo raid validated LeMay's gamble in terrifying fashion. Intelligence warned losses could reach 70%. That didn't happen. Few bombers were lost, but over 100,000 people died in the firestorm. From the Marianas, the B-29 campaign could launch huge strikes like the March 9th operation involving 279 B-29s, destroying about 15.8 square miles of the city. LeMay also scaled raids up. What started as smaller missions grew into mass attacks, rising from around 60 planes to as many as 300 aircraft. Crews flew steadier courses instead of constant evasive maneuvers because the plan depended on getting bombs down in volume. By the end of this shift, Japan's industrial output was reduced by about 40% before summer's end. This change wasn't clean or comfortable. It was strategy under pressure. Early 1945 marked a sharp turn from precision first to city first. Disappointing high-altitude results forced commanders to accept hard facts about wind, clouds, and Japan's dispersed industry. Experimental incendiary raids, like the Hankow mission, showed how effective fire attacks could be against flammable urban construction. Engineers then modified B-29s quickly by removing defensive gear and even some sighting equipment, creating space for larger bomb loads and better performance at lower altitude. And the B-29 wasn't only a city burner, it also became a sea blocker. In March 1945, at Admiral Nimitz's request, Operation Starvation began, an aggressive mining campaign that used the B-29's reach in a way older bombers couldn't match. In just 5 months, B-29s of the 313th Bomb Wing dropped over 12,000 mines in 1,529 sorties. They targeted key shipping lanes, especially the Shimonoseki Straits, where nearly half the mines were laid. The plan moved through 5 phases, and the 6th Bomb Group played a key role in phases 1, 2, and 5. The results were devastating. Shipping through the straits collapsed by 98%. Japanese vessel losses reached about 670 ships, around 1.25 million tons. And the efficiency was brutal. B-29s sank about twice as many ships per month as submarines, while suffering minimal losses, about 15 to 16 aircraft. None of this happens without islands. The Marianas, Saipan, Tinian, and Guam became the pivot point of America's Pacific strategy. Captured in 1944, they put Japan's homeland inside the B-29's roughly 3,000-mile reach. That made sustained bombing possible and turned the campaign from awkward to overwhelming. By war's end, these islands hosted nearly 1,000 superfortresses. And they weren't just runways. They became a massive logistics hub, with maintenance facilities that could do complex repairs that once required factories back in the United States. Remote coral islands became industrial powerhouses, feeding the strategic bombing machine. That came at a cost. These bases were secured through brutal amphibious landings against Japanese forces prepared to fight to the death. The broader push included the fierce naval and ground battles of Operation Forager. Theatre priorities shifted. Grabbing airbasing mattered as much as, or more than, simply hopping closer to Japan. The US poured in massive resources: fleet carriers, battleships, and over 127,000 troops, because these islands would serve like an unsinkable aircraft carrier. Admiral Chester Nimitz coordinated the command structure, organizing Fifth Fleet resources to seize and build these bombing platforms. Each captured island wasn't just a victory. It was a step in a larger system meant to keep B-29s flying non-stop. Even after the islands were taken, the B-29 faced a problem that nearly wrecked the program: its engines. The Wright R3350 was powerful but notorious for overheating and fires. Keeping Superfortresses flying demanded a maintenance revolution. Mechanics on primitive Pacific airfields did the impossible. They replaced uppermost cylinders every 25 hours and sometimes replaced entire engines every 75 hours. They added asbestos baffles around fittings to prevent oil loss. The turbo-supercharged engines required new maintenance routines that changed what field repair meant. This push built on a major stateside effort called the Battle of Kansas, where modification centers delivered 150 combat-ready superfortresses in just 5 weeks. On island bases, inspections became intense. Crews did careful magneto checks during rollout to reduce fire risks right after takeoff. This forward maintenance network helped support around 31,000 sorties over about 13 months, keeping pressure on Japan even while operating a complex aircraft from coral runways. Before the Marianas solved the supply line, the whole B-29 idea almost choked on logistics. In the CBI theatre, the supply situation was a nightmare. Fuel and bombs had to be shipped to Calcutta, then flown over the Himalayas, the hump. The B-29 required new infrastructure everywhere: longer, stronger runways and dedicated fuel pipelines. 5 Bengal airfields were built far behind schedule. Fuel shortages constantly limited missions, even while commanders demanded more attacks. When LeMay later removed defensive gear, it wasn't only about tactics, it also helped increase bomb and fuel capacity when supplies were tight. The situation didn't truly stabilize until the Marianas bases connected directly to US supply lines by ship, finally solving the logistical puzzle that had threatened the whole long-range bombing concept. Now add the part many people forget. The B-29 didn't just change strategy, it changed what crews could physically endure. The pressurized system was a major leap. Crews worked inside 3 separate pressurized compartments connected by a long tunnel that bypassed the unpressurized bomb bays. A Garrett air research system protected them from brutal cold, down to about -40 degrees Fahrenheit at altitudes reaching roughly 31,850 feet. Imagine the difference. In earlier bombers like the B-17 and B-24, gunners often sat exposed in open turrets. In the B-29, gunners stayed in climate-controlled sections. The forward compartment held 6 crewmen, including pilots and the bombardier. 4 worked in the rear section. The tail gunner sat in his own pressurized space. This mattered because long missions demanded clear thinking. The B-29 let crews stay sharper while carrying heavy loads deep into enemy territory, and its performance reduced the need for fighter escorts on many missions. Defense was reinvented too. The B-29's General Electric Central Fire Control System was unlike anything in earlier bombers. 5 interconnected sighting stations controlled 8 remotely operated 50-caliber machine guns in 4 turrets. The tail position was manned and carried 2 50 cals, plus a 20mm cannon. Instead of guessing lead and distance by feel, gunners used optical sights, while analog computers did the math, range, speed, lead, and ballistic correction. Each computer sat in a 3/8-inch thick steel case, weighing over 50 pounds. A gunner could track a fighter, dial in wingspan, and the system handled targeting calculations, extending effective firing range to about 900 yards, roughly twice what many enemy fighters could manage effectively. If a gunner was knocked out, control could transfer to others. Safety interlocks helped prevent firing into the aircraft itself. The combat record linked to this system was striking. About 914 victories against 72 losses across roughly 31,000 sorties in 1944-1945. Then there's the raw muscle, payload. The B-29 could carry up to 20,000 pounds, reshaping mission planning. It delivered about 4 times the payload of a B-24 and 5 times that of a B-17, while also flying higher, faster, and farther. The bomb bays were flexible, allowing many smaller bombs or fewer massive weapons. In overload combat conditions, a B-29 could take off at about 135,000 pounds. Its service ceiling was near 32,000 feet, and it could fly beyond 4,200 miles with full payload. Pressurization, heating, and oxygen weren't comfort extras. They were what made long-range, high-altitude missions possible. That payload power explains why stripping weight mattered so much. Once the new low-altitude night strategy took over, crews dropped incendiaries designed to ignite Japan's vulnerable construction. M47 clusters, magnesium bombs, phosphorus, napalm, and other fire-starting loads. They flew under cloud cover to avoid weather delays. They leaned into mass, using large formations to overwhelm defenses and deliver more bombs per plane. The result wasn't just destruction. It was a direct attack on the war economy inside urban industrial areas, not only isolated factories. Behind the scenes, one secret program was shaping the final chapter. In October 1943, Silverplate began. Dr. Norman Ramsey identified the B-29 as the only aircraft suitable to deliver atomic weapons at the needed range and altitude. These Silverplate B-29s were modified heavily, with pneumatic, eyelid bomb bay doors and an added weaponeer station to monitor bomb release. By mid-October 1944, the first 3 modified bombers arrived at Wendover Army Airfield in Utah. The 509th Composite Group trained intensely, dropping about 155 dummy bombs before being declared combat-ready in February 1945. They deployed to Tinian by June, and key personnel like Parsons and Ramsey arrived in July. The program even considered using the British Avro Lancaster at first, but the B-29 won because of its range and high-altitude performance. Silverplate continued after the war, too. By 1948, 225 additional bombers were modified for nuclear capability, and the program ran until it ended in 1951. All of this came with a price tag that still shocks people. The B-29 program cost about $3 billion during the war, more than the Manhattan Project by over $1 billion. In today's terms, that's around $52 billion. It began with a $3.6 million contract for 2 prototypes, then ballooned as production surged. Each fully equipped B-29 cost over $618,000. The base aircraft ran $363,036, plus around $250,000 for engines, equipment, and weapons. Total spending reached about $3.7 billion for nearly 4,000 aircraft. It was a huge gamble. Roosevelt promised bombing runs over Japan, pushing rapid development even while the plane still had major issues. When the first combat mission lost 6 aircraft, critics questioned the entire investment. But the hard truth was simple. Only the B-29 could deliver atomic weapons at the ranges required. The B-29 also changed how America built aircraft. It compressed what was normally a 5-year development cycle into about 3 years. Design, testing, and production happened at the same time. Pressurized cabins demanded new sealing methods. Remote turrets required electric and gear systems never built at this scale before. When the R-3350 engines overheated catastrophically, engineers redesigned cooling systems while planes kept rolling off assembly lines. Combat units fed real-world data back into modification depots, creating a fast feedback loop that became the blueprint for modern military aircraft programs. Workers at places like Boeing Wichita often pulled 80-hour weeks through 1944 to meet demand. The B-29 also offered commanders something earlier bombers couldn't: real flexibility in altitude. It was designed for high-altitude work near 32,000 feet and speeds up to about 350 miles per hour. But when jet streams and clouds ruined the original plan, the same aircraft could shift to low-altitude night raids, sometimes around 5,000 feet. That adaptability mattered. It allowed heavier loads, often around 12,000 pounds in the low-level profile, better navigation, and less engine strain in some conditions. Later B-29B models even cut weight by removing most gun turrets for dedicated, low-altitude incendiary missions. When the war ended, the B-29 didn't fade away. It became the foundation for Strategic Air Command's nuclear deterrence, meaning a force meant to scare the other side into not attacking. The B-29 served as SAC's primary nuclear platform in units like the 92nd Bomb Wing until newer bombers arrived. It was eventually replaced by aircraft like the B-50 and B-36, but the logic and lessons stayed. And when B-52s entered service in 1955, they inherited a strategic framework the B-29 had already proven. The nuclear impact ran even deeper. Hiroshima and Nagasaki showed the world devastating power delivered over extreme distance. After the only nuclear weapons ever used in combat were dropped by B-29s, American strategy shifted toward nuclear deterrence as the center of planning. The 20th Air Force, which had managed B-29 operations, later evolved into a force tied to America's ICBM arsenal, maintaining around 500 Minuteman and 50 Peacekeeper missiles. The B-29's record, around 31,000 sorties with relatively low losses, helped validate strategic bombing as a war-deciding tool. And its long missions, sometimes around 1,500 miles, at altitudes near 31,850 feet, helped build the foundation that still influences modern strategy when leaders worry about countries trying to get nuclear weapons. So yes, the B-29 is remembered for 2 bombs. But the bigger story is what it did to American bomber strategy before that moment. It gave the US true long-range reach. It exposed the limits of precision in real-world winds and clouds. It drove a brutal shift to low-altitude fire raids. It mined Japan's waters with Operation Starvation and strangled shipping with shocking efficiency. It turned the Marianas into an industrial launch pad. It forced new maintenance systems, new development methods, and a new way to think about human performance on ultra-long missions. And after the war, it left a blueprint that shaped Strategic Air Command and the Cold War mindset. But the B-29's story doesn't end with victory parades. In some ways, that's where the most dangerous chapter begins. The war ended. Factories slowed down and crowds went home. But the B-29 didn't simply retire. It stepped into a new kind of conflict, one built on fear, distance, and the idea that the next bomb could end everything. In 1946, the US wanted to answer a chilling question. What would an atomic bomb do to a navy? Not a city, a fleet. So they set up massive tests in the Pacific, with warships anchored like targets on a shooting range. Then a B-29 flew out and dropped an atomic bomb over the test area. Blue ocean below, steel ships beneath, and a shockwave that didn't just bend metal, it bent old thinking. It proved something terrifying. Modern war didn't need an army to reach your shore. It needed one airplane and one bomb. That lesson spread fast. And then came another twist, one that felt like a spy story. During the war, a few B-29s landed in Soviet territory after missions, damaged and low on fuel. The crews were interned. The aircraft were not returned the way you might expect. Instead, the Soviets studied them. They didn't just take notes, they copied the aircraft piece by piece, bolt by bolt, system by system. Soon, the Soviet Union had a bomber that looked like the B-29 for a reason. It was built from the B-29's shadow. Now think about what that meant. For a short time after World War II, the US had the long-range bomber advantage. The B-29 was a symbol of reach. Then suddenly, that symbol had a mirror image on the other side of the world. So the question became simple and terrifying. If both sides can build bombers like this, what happens when both sides also have the bomb? That's where the biggest shift happened. Not a new airplane, but a new mindset. The United States built a force around one idea: always be ready. Ready at 3 a.m., ready in bad weather, ready even when crews are tired and machines are stubborn. Bombers were no longer just tools of war, they became tools of national survival. The B-29 became a backbone in that early period. Bases were upgraded, crews trained constantly, rules got tighter. The goal wasn't only to fly, it was to be able to launch on short notice, strike far targets, and complete the mission. But always ready has a dark side. It brings more accidents, more stress, and more mistakes. When you push humans and machines every day, something eventually breaks. And with a plane like the B-29, breaks could mean fire, crash, explosion, or losing something you can't afford to lose. At the same time, technology kept moving. The B-29 was a piston-engine giant, but the future was jets. That created an awkward in-between era. The B-29 was still powerful, but everyone knew it couldn't stay on top forever. So the Air Force looked for a bridge, ways to stretch the design, improve performance, and keep the mission alive while the jet age grew up. Some B-29s evolved into improved versions with stronger engines and better performance, trying to squeeze more life out of the basic design. Others were turned into support aircraft, tankers to refuel planes mid-air, weather planes to hunt storms, and test platforms used to push new ideas into the sky. The B-29 stopped being only a bomber, it became a toolkit. Then, just when it seemed like the next era would be planning and standoffs, the world exploded again. In 1950, war broke out in Korea, and suddenly the B-29 was back in combat. At first, it looked familiar. Big bombers, long missions, dark skies. The B-29 hit bridges, rail yards, supply lines, and industrial targets. Early on, it could still do the job. It had experienced crews, heavy payload, and real reach. But Korea wasn't Japan in 1945. The sky had changed, because now there were jets. Jet fighters could climb faster and attack with speeds the B-29 wasn't built to face. Yes, the Superfortress had guns. Yes, it had trained crews. But it wasn't designed for a world where fast jets could slash through the air like blades. That forced another shift. More night operations, new routes, new escort planning. The bomber that once felt almost untouchable now had to respect a new kind of threat. It was a harsh lesson. The B-29 helped invent modern air war, but modern air war didn't stop evolving for the B-29. It could still fight, but it was no longer the future. It was the present trying to survive. And while Korea burned, the Cold War pressure kept building behind it. The biggest fear wasn't just a battle on a hill, it was a surprise strike across continents. So bomber crews trained for missions they hoped would never come. Imagine sitting in a briefing room and hearing, "You might be called tonight. You might take off in the dark, and the world might change forever because of what you carry." That pressure shaped a new bomber culture. Less glory, more discipline. That pressure also pushed the US to move faster into jets and greater reach. New bombers were coming, faster, higher, built to survive a jet world. And the B-29, despite everything it did, began to step aside. But it didn't disappear overnight. Some B-29s stayed in roles that didn't make headlines: training, testing, support, refueling, weather tracking, long patrols. Quiet work that still mattered. Because even when a warplane stops being the tip of the spear, it can still be the arm holding everything up. And the B-29 left behind more than missions and metal. It left behind a blueprint for how a superpower thinks. First, distance is a weapon. If you can reach far targets reliably, you can shape decisions before anyone fires a shot. Second, technology changes the game plan. When your aircraft can fly farther and carry more, your strategy can't stay the same. Third, logistics is power. A bomber isn't just built in a factory, it's kept alive by fuel, parts, bases, mechanics, and planning. Fourth, readiness becomes a lifestyle. In the Cold War, the bomber force didn't train to win one battle. It trained to prevent a war, or end one instantly if it started. And fifth, your enemy learns from you. Sometimes they steal, sometimes they copy, sometimes they adapt faster than you expect. That last point should make you pause. The B-29 wasn't only a symbol of American power, it became a lesson the world studied: how to build reach, how to deliver massive force, and how to create fear without firing a shot. So when you picture the Superfortress, don't picture it only over Japan in 1945. Picture it over empty ocean during nuclear tests. Picture it sitting on runways during tense standoffs. Picture it flying into Korea, facing jet fighters that proved the world had already moved on. And picture the moment both sides realized the same truth. The future of war wasn't only about who had the biggest army. It was about who could reach farther, faster, with weapons that changed everything. Next time, we go one step deeper into the part nobody wants to imagine. How bomber crews lived with this pressure every day, what nuclear readiness really looked like, and the close calls that almost turned training into disaster.